Hello, good evening, students. Welcome you all for this third session on redox reaction. Till now, till now, we have studied about what exactly is oxidation, what is reduction, and then we learned various types of redox reaction. Yes, combination, decomposition, displacement, intermolecular, intramolecular. Yeah, then balancing of reaction, oxidation number method, and balancing of reaction, half reaction method. These are the two methods which are very important. They are like the key thing in redox reaction. So this almost completes the chapter. Okay. Most of the questions will be from balancing of reactions only. Some intermediate step they may ask in some competitive exam. Okay, electron gain, electron lose, all of those things we will be learning today. So just to recollect what we have learned in last class mainly oxidation number method and how we can define oxidation and reduction using oxidation number. Yes, if there is increase in oxidation number, it is oxidation. If it is decrease in oxidation number, it is reduction. Clear? Yes, and also, we saw that in for any reaction to be balanced, oxidation should be supported with either reduction or an addition of electron. Yes. So, what is this oxidation number method? It is one of the technique to solve the redox reaction. Till now, whenever balancing of reaction was there, we were using hit and trial method, right? Okay, carbon has to be balanced, so multiply with the respective number of moles. Yeah, and something else has to be balanced. So in a way that it was hit and trial. Yeah, but now we have some precise way to solve any redox reaction. Okay. So this is one example, dichromate ions reacting with sulfide ions to form chromium ion and sulfate ion. So in this technique, what we do is initially we will see how much is the increase in oxidation number and we try to balance that with decrease in oxidation number. Remember this, okay? In both the techniques, finally this is what we are going to do. But in oxidation number method, we approach in one particular way and in half reaction method, we approach in another way. But the point is that increase in oxidation number should be balanced by decrease in oxidation number. Because, for example, if I take the Cr2O7 2 minus getting converted to Cr3 plus, if I try to find out the oxidation number, for Cr, it is one atom of Cr will have a charge, notional charge of plus 6 or oxidation number is plus 6. And when it gets converted to Cr plus 3, okay, yeah, chromium in the solution, it will be Cr3 plus state. So when it changes from plus 6 to plus 3, every atom, please note down this, that every atom of chromium is changing from plus 6 to plus 3. So since here two atoms of chromium is there, I can balance it to write 2Cr. Okay, so when I balance it to write 2Cr, then the change in charge for two atoms will be 2 into plus 6 to 2 into plus 3. Correct? Is the increase in oxidation number clear to you? So, what does that mean? The notional charge of chromium in the reactant and the notional charge of the chromium in the product, the difference of those two is increase in oxidation number. Clear? So it is 2 into plus 6 and in the product it is 2 into plus 3. So difference is how much? Difference is 12 minus 2 into plus 6 is 12 and 2 into plus 3 is minus 6. So which is 6. So difference in oxidation number is 6. Okay. Whereas for S, for sulfur, what it is? So sulfur, what it is? Let's try doing that. So initially I found out oxidation number of all the entities, and I have to also find out which one is getting oxidized, which one is getting reduced. And once I found out that, I have to see what is the increase in oxidation number of one which is getting oxidized, and what is the decrease in oxidation number of one which is getting reduced. So we found that for this, the increase in oxidation number is 6. Okay, now let us look at the reduction part. If you see reduction, okay, this was the decrease in oxidation number. Yeah, sorry, it was decrease in oxidation number, right? Because plus 12 to plus 6. Plus 12 decreases to plus 6. So it is decrease in oxidation number. Chromium gets reduced. Okay. Sulfur gets oxidized. Plus 4 to plus 6. So it increases. Plus 4 to plus 6. Okay. So what is the increase in oxidation number? Since there is only one sulfur atom, I need not to multiply it with anything. It itself will represent, that is plus 4. Since I have to consider only difference, plus 6 minus 4, which is 2. Okay, so the decrease in oxidation number is 2, and decrease in oxidation number is 6, because chromium is getting reduced. Okay, don't get confused. Chromium is getting reduced, so decrease in oxidation number is 6 for 2 atoms of chromium, and increase in oxidation number of sulfur is 2. Because there is only one atom, I need not to multiply it with 2. It is directly 6 minus 4, which is 2. But this oxidation number method says that we have to balance this as well as this. There is only one way to balance it. How it is? You multiply this with 3 and this with 3. Because if you multiply 2 with 3, you will get 6. Got it? So when you multiply for sulfur into 3 and on product also with 3, then you can see the change in charge will be 12 over here. For 3 atoms, it will be 3 into 4, 12. And here it will be 3 into 6, 18. The difference is now 6. So by this, I am balancing my increase in oxidation number of sulfur with respect to decrease in oxidation number of chromium. So now I can say that chromium in reactant and product is balanced. Sulfur in reactant and product is balanced. Only thing that is not balanced is, the multiply by suitable factor. What is that suitable factor? That is, in my case, 6 by 2. Decrease in oxidation number by increase in oxidation number. Whichever factor will balance out decrease and increase. Okay? Yes. To make it more simple, I'll rewrite it. Cr2 6 plus to Cr3 plus, increase in oxidation number. Sorry, again I am writing the same thing. It is decrease. Decrease in oxidation number is 6. Right? For this it is 6. And for SO3 2 minus to SO4 2 minus, the increase in oxidation number is plus 2. Okay, yeah. So if I want to balance, I have to multiply this increase in oxidation number into 3. Correct. So that's the reason I have to multiply this equation into 3. Okay. So when I multiply this equation by 3, then it will be 3SO3 2 minus. Yeah, this equation will become 3SO3 2 minus, giving 3SO4 2 minus. And now for this, increase in oxidation number would be equal to 6. Clear? You can write down both equations separately and then do. That's also all right. Okay. When you write down reduction reaction separately, oxidation reaction separately, and try to balance their increase and decrease, then whatever the balance happens, that itself will be the balancing of reduction, the element which undergoes reduction and element which undergoes oxidation. Yeah. Yes. So this is what I'm going to get. But now in this, you can see that oxygen on reactant side, that is 7 plus 3 to 3, 9, is 16, is not balanced. Here it is 12. Okay. So in this technique, you will be able to balance everything. Oxygen and hydrogen is the only thing that will remain at the end. So for balancing oxygen and hydrogen, there are two methods. Okay. When it is acidic medium, there is one way, and when it is basic medium, there is another way. So for acidic or neutral solution, how do we solve? Listen very carefully. For acidic medium, when you are conducting experiment in acidic medium, you have only H plus in water. Correct? Acidic medium means what? H plus in water. Yeah. So I can use H plus, I can use water. That's all. So in that case, how to balance equation? Wherever oxygen is less. Okay. Wherever oxygen is less. In this case, as you can see here on product side, only 12 oxygens are there. On the reactant side, 16 are there. So 4 oxygen you need to add. So when you want to add 4 oxygen, you do so by adding 4 water molecules. Got it? So in acidic medium, you add water to the side where oxygen is less. Okay. And whatever hydrogen imbalance comes, that you balance by adding H plus on the other side. Okay. So here you can see when I add water, 8 H plus, 8 hydrogen will become surplus. So I'll add that over here as 8 H plus. Yeah. By this, my reaction will be balanced. Clear? I'll repeat again. For acidic and neutral solution, we balance oxygen in the beginning by adding water wherever oxygen is less. Okay, how many moles? How many moles it is less? We are adding that many moles of water. And to the other side, or wherever hydrogen is lacking, hydrogen is less, I balance it by adding H plus. Okay, how much ever is needed. Clear? This is how I solve when it is acidic solution. And when it is basic, when it is alkaline medium, then the oxygen, again the same thing, here 16 is there, here 12 is there. So 12 oxygen, I need 4 more oxygen. So that 4 more oxygen to balance, I need to add twice amount of hydroxide, because the alkaline solution means I don't have H plus, I have only OH minus and water, right? So I have to use only OH minus and water. So initially what I'll do, I'll use 2 times OH minus. Okay. And other side, if I'm using 2 moles over here, other side I'll have to use 1 mole H2, half. Basically it means half. So here in this case, 4 oxygens are less. So I need to add 8 hydroxide, right? Twice of number of oxygen less. Okay, here number of oxygen less is 4. So twice of 4 you need to add on the right side. So, and then half of it you have to add on the left side. 4H2O you will add on the left side. Then the reaction will be balanced. As you can see, here 8 hydrogen is there. Here also 8 hydrogen is there. Here 8 oxygen is there. Here 4 oxygen gets added, 16 plus 4. Here 8 oxygen gets added, 12 plus 8. So both became 20. The reaction is balanced. Understood? Yes. I'll just do quick revision of oxidation number method. In oxidation number method, initially we'll write the equation properly, and then we'll find out oxidation number of all the entities, and we'll find out which one is undergoing oxidation, which one is undergoing reduction. And we'll find out increase in oxidation number and decrease in oxidation number with respect to how many atoms are present. Okay. For example, Cr2 if it is present, then the oxidation number will be double, right? Because notional charge for one atom is, it was plus 6. For 2 atoms, it will be plus 6 into 2, 12. So oxidation number will become double if there are 2 atoms. So finally, what should be there? Increase in oxidation number should be equal to decrease in oxidation number. Yeah. So this, if I balance, my oxidation entity and reduction entities are balanced. Later, I need to balance oxygen and hydrogen. Oxygen I can balance in case of acidic medium by adding H2O, and whatever imbalance of hydrogen comes, that I balance it by adding H plus. Yeah. And in case of alkaline medium, I add twice as much as difference of oxygen, and half of it as H2O on the other side to balance hydrogen as well as oxygen. Yeah. So if this is clear, try to solve this question. MnO4 minus Br minus giving MnO2 and BrO3 minus. Yeah, try this out. Initially, the first step is find out oxidation number and find out which one is undergoing oxidation, which one is undergoing reduction. Okay. Yes, yes. You can write down which one is undergoing oxidation, which one is undergoing reduction. You can reply for that. Yeah. Yeah. For this, I would want reply from all of you. Okay. Since 5 students have joined, let's see who. It's quite easy. Yeah. Oxidation number is nothing. Now it should be very easy for you. Find out oxidation number. Yes. How much it is? Yeah. Here it is plus 7. Here it is plus 4. Isn't it? So plus 7 to plus 4. Okay. What about Br minus and BrO3 minus? Answer it quick. Br minus BrO3 minus. Yeah. Can tell me quick. Yeah. Reply. Yeah. So which one is undergoing oxidation and which one is undergoing reduction? Yeah. Br minus to BrO3 minus. It is minus 1 to plus 5. You can cross validate. Just you have to take oxidation number as minus 2 in all this case. So then you will get plus 7 minus 1 plus 4 plus 5. Okay. So Br minus, as you can see here, it is undergoing oxidation. Yes. And MnO4 minus to MnO2. Yeah. Plus 7 to plus 4. It is undergoing reduction. Yeah. So this one is oxidation and below one is reduction. Now you try to balance this. Yes. The change, decrease in oxidation number. Just tell me what will be decrease in oxidation number? Yeah. There is no reply. Try responding. Okay. So decrease in oxidation number plus 7 to plus 4. It decreases. So 7 minus 4, 3. And increase in oxidation number. Increase in oxidation number. The difference is how much? Plus 5 minus 1 becomes plus 5. So 5 minus of minus 1 is 6. Now, is there only one atom of each entity, the oxidation and reduction? Yes, right? MnO4, manganese is only one atom, and even on the product side, it is only one. Br also one. Br in BrO3 minus also, Br is 1. Okay. Yeah. So, yeah, now decrease in oxidation number, that is reduction is 3 and increase in oxidation number, oxidation it is 6. Okay, so to balance reduction, I need to multiply it with how much? I need to multiply it with 2, correct? To balance out the reduction as well as oxidation reaction. So that's why I'll find out which one is reduction. Manganese is reduction. I'll multiply that with 2. Clear? Because decrease in oxidation number should be equal to increase in oxidation number. Reduction reaction needs to be multiplied with 2. So that decrease in oxidation number also becomes equal to 6. Clear? Yeah. So now, as you can see, this oxidation reduction entity as well as oxidation entity both are now balanced. Only thing is oxygen needs to be balanced. So what is the question saying? Question is saying that it is in basic medium. Permanganate ion reacts with bromide ion in basic medium to give manganese dioxide and bromate ion. Okay. So basic medium. Basic medium means what? Find out how much oxygen imbalance is there and add you have to add twice hydroxide of it. Okay, so here as you can see 8 is there on left side, on reactant side, 2 into 4 it's 8, and on the product side it is 2 into 2 4 plus 3 7. Okay, so 7 is there on the right side and 8 is there on the left side. So what is the imbalance? Imbalance is of 1. Where it is less? Right side. So right side I have to multiply it with or add 2 times hydroxide. Correct? So I have to add 2 OH minus ions on right side. Okay, where it is less. Okay. So it will be 2 times OH minus. Clear? So now only one thing needs to be balanced. H. Right? H I can balance by adding half of this the other side, which will be H2O. Clear? Yes. Simple, isn't it? Yeah. But now let me come to competitive exam perspective. In competitive exam perspective, question may come in this reaction. In this reaction, MnO4 minus Br minus giving MnO2 and BrO3 minus. In this reaction, find out the change in oxidation number. Okay, the balanced reaction. Okay. Like that question may come. So it will be 6. Clear? Or it can be furthermore in depth also, okay, wherein they may ask how many hydroxide ion are required to balance. Yeah, it can be little more in depth also. Yes. Going ahead, another method which is half reaction or ion electron method. So basically, here we'll try to balance out electron or charge on the both sides. Has to be balanced. That is the principle on which we do half reaction method. And hopefully, I think all of you will like half reaction method more than oxidation method. Okay. At the end, you can comment which you like. Yeah. Let's start with this example. MnO4 minus in basic solution oxidizes iodide ion to produce molecular iodine and manganese oxide. Write balanced ionic equation to represent this redox reaction. Same like first method, which was oxidation number method. I will write down that equation as it is, and then I'll find out oxidation number. Yes. After finding out oxidation number, we convert it into something called as half reaction. What is that? Oxidation reaction, which is I minus to I2. I'll write it separately. Reduction reaction, which is MnO4 minus to MnO2. I'll write it separately. Okay. So now only one thing is remaining to me, that I have to balance oxidation as well as I have to balance reduction. Clear? So oxidation, how can I balance? Oxidation reaction. Initially, here the simple balance method we use, wherein I'll just multiply it with 2 so that number of iodines got balanced. Simple technique, nothing much. And manganese is already balanced. One manganese and another manganese. It is already balanced. Okay. Yes. So 2I minus, I'm giving I2, will balance out iodine, and Mn is already balanced. So now next step is to balance this oxygen. Okay. Here four oxygens are there. Here two oxygen. So I have to add two more equivalent oxygen. It is basic medium. Since it is basic medium, instead of adding two O, I'll add four OH minus, twice of need, correct? So two are needed. So I'll multiply four hydroxide and I'll choose. And after that, once this is done, H has to be balanced. So how will I balance H? By adding H2O on the other side. And how much H2O I should add? Half of this, which is 2H2O. Clear? Yeah. Is that clear? Till here it is clear that oxidation reaction will take it separately, reduction reaction will take it separately. Oxidation reaction, that number of entity needs to be balanced. Oxidation number need not be balanced. That we will balance at the end. Okay. And in reduction reaction, the entity which is undergoing reduction, that needs to be balanced. Once that is balanced, both on the oxidation side as well as the reduction side, we need to balance oxygen as well as hydrogen. Clear? Yes. So how to balance oxygen and hydrogen? Same way. If it is alkaline, use hydroxide and water. If it is acidic, you use H plus and H2. First use H2 and then use H plus. Clear? Once this is done, final tinge of thing is remaining, which is charge balance. So if you see here, it is -1 on the LHS or reactant side and -4 on the RHS. Okay. Here if you see -2 on the LHS and 0 on the RHS. So finally, I need to balance this. And how will I balance this? By adding 2 electron over here. When I add 2 electron, what happens? Here -2 charge is there. Here also -2 charge is there. So it is balanced. And here -1 charge is there. Here -4 charge is there. So by adding 3 electron, I get another -3. So -1, -3, and -4. So -1 -3 is -4. LHS equal to RHS. So both are balanced. By that what I mean is both are balanced. Okay. Next, I need to multiply with certain number. These two I need to multiply it in certain number, that when I add both of this and this gets cancelled, because in any reaction we don't see that electrons get generated out, right? So whatever electrons is there in the product side of oxidation should be balanced with the electrons present in the reduction side. So how I'll do that? I'll multiply this side with 3, this side with 2. I think you should be knowing this, isn't it? Yes. So when I multiply it with 3 on the oxidation side and 2 on the reduction side, I'll get 6I minus. Here it is saying the same thing. If the number of electrons in each reaction is not matching, we have to multiply reactions on both sides by suitable factor. Here the suitable factor will be 3, so that 3 into 2 is 6. Here the suitable factor is 2, so that 3 into 2 is 6. So 6 and 6 will be balanced. Okay, and then when I multiply this with 6, the first above reaction with 3, it will be 6I minus, giving 3I2 plus 6E minus. And whereas for this, it will be 2MnO4 minus plus 4H2O plus 6 electron. Now, since I have multiplied it with 2, MnO2 plus 8OH minus. And then upon adding, we will get the final reaction. Okay. So this is how we balance in half reaction method. Okay. First, oxidation number we have to find. Then we have to find out which one is undergoing oxidation, which one is undergoing reduction. Clear? And then take out oxidation part separately, reduction part separately. Okay? Yes. And balance the oxidation entity, balance the reduction entity. Okay? Once that is done, you balance the excess oxygen or excess hydrogen on both oxidation side and reduction side. You all know how to do that, right? Once that is done, balance the charge by adding electrons both on oxidation side as well as the reduction side. Make sure that the electron on the oxidation side and the electron number of electrons on the reduction side are same, okay, by multiplying it with suitable factor. Once that is done, you can directly add and you will see that this 6 electron and this 6 electron will cancel out and giving us the uh, balanced equation. And you can validate whether your equation is correct or not by doing three things. Or rather, two things is sufficient. You check whether all the entities are balanced. Here 6 iodine, here also 6 iodine, here 2 manganese, here also 2 manganese, here 8 plus 4, 12 oxygen, here 4 plus 8, 12 oxygen, hydrogen, here 8 are there, here 8. So all are balanced. That is first thing. All entities are balanced. And second thing that you need to check is whether charge is balanced on LHS as well as RHS. Here you can see 6 minus, so that means minus 6 is charge over here. Here it is 2 into minus 1, which is minus 2, whereas over here it is 8 into minus 1, which is minus 8. So minus 6 minus 2 is minus 8 on the LHS and minus 8 on the RHS. So charge also has to be balanced. So if these two things are balanced, then your redox reaction is balanced. Note, when question comes on redox reaction, don't use hit and trial method to do, because you may get first one correct. All entities may be balanced, but charge may not be balanced. Okay, so either use half reaction method or use oxidation number method. Okay. Yes, so I think half reaction method is much easier than oxidation number method. Okay. Just try doing this. Oxidation of Fe2 plus ions to Fe3 plus and dichromate Cr2O72 minus to Cr3 plus in acidic medium. Yeah, acidic medium. So you have to balance oxygen using H plus and H2. Try doing this. Yes. Try doing this. First step, finding out oxidation number. Second step, finding out which one is undergoing oxidation, which one is undergoing reduction. So write oxidation reaction separately, which we call it as half reaction, and write reduction reaction separately. Okay. Yes, I think till here you should be able to do. At least message me the chat box that which one is undergoing oxidation and which one is undergoing reduction. Quickly. Yes. Which one is undergoing oxidation? Which one is undergoing reduction? Yes, please try to answer. Otherwise, yeah, there is no feedback from you all, whether you are understanding or not. Which one is undergoing oxidation? Quite obvious, quite visible also. So oxidation is Fe2 plus to Fe3 plus, right? Because plus 2 increases to plus 3. And here reduction is plus 6 to plus 3, that is Cr. Cr2O72 minus to Cr3 plus. So how to balance it? The first step is balance the oxidation entity and reduction entity. So oxidation entity we need not to balance. Reduction entity we need to multiply it with 2. Yes, multiply this with 2, it will be balanced. Yeah. What is next step? Balance the oxygen. Balance oxygen atoms. Here there is no oxygen, so need not to balance. Here, how to balance it? By adding, since it is acidic medium, we need to add what? Water, right? So, how much water to add? Here, 7 oxygen is there on the reactant side, so we need to add 7 water molecules on the right side. So, by that, the half reactions are partially balanced. Now, next balance is charge balance, correct? Number of electrons. So if you see on the this side, Fe2 plus to Fe3 plus, here I need to put another electron on the right side, isn't it? Because then only 3 minus 1 will give plus 2. Whereas in this case, here 2 minus is there, here 2 into 3, 6 is there. So minus 2 and 6. How to balance this? By adding 8. Okay, I think hydrogen needs to be balanced before that. When we balance hydrogen, it becomes 14H plus. And now if I try to find out the charge imbalance, it will be minus 2 plus 14 and 6. So 14 minus 6, 14 minus 2, which is 12, and here it is 6. Yeah, 2 into 3, 6. So to balance that, I'll add plus 6E minus, which is minus 6. So 12 minus 6 will become 6. Always remember, in oxidation reaction, this will come to the product side. In reduction, this will come to the reactant side. That's why I think oxidation and reduction was also defined in this manner, that the entity which undergoes oxidation gives out electron, the entity which undergoes reduction consumes electron. Okay, it was for this reason. Okay, and also in indirect redox reaction, we learned that oxidation and reduction are carried out separately, and the process is completed by flow of electron from one container to another container. And how is that happening? Oxidation is undergone in one chamber, and from there electrons travel to the other to complete. See here, electrons are released out. Here electrons are needed, which comes out from oxidation. So these are various things which depends upon this knowledge, that oxidation means electrons are lost, reduction means electrons are consumed. Okay. Yes. So once this all things are balanced, now what needs to be done? We should make sure that here number of electrons should be equal to here number of electrons. To make that, I'll multiply with suitable factor, which is 6. So 6 and what it will be? Sorry, here it will be 1, right? Because here I need not to multiply it with anything. Here it will be 1. Here it will be 6. When I multiply it with 6, it will be 6 Fe2 plus, yes, 6 Fe3 plus and 6 electron. Now it is fully ready for addition. So if I add both of them, I'll get this expression. Got it? Yes. So hope it's clear. Yeah. So these are the two methods which are quite important. So be like, you can practice more questions on this type, and especially finding out number of electrons. Okay. Also questions can come this way, that let's say this is the redox reaction, some reaction is a redox reaction. Calculate the number of electrons exchanged in this reaction. So in the same reaction that I'm taking, Fe2 plus giving Fe, converting into Fe3 plus ion, and dichromate ions getting converted to Cr3 plus ion. In the same example, how much electrons has been exchanged from oxidation to reduction? As you can see, 6 electrons are left by this oxidation and 6 electrons are consumed by reduction. So whatever oxidized gets whatever electrons comes out during oxidation gets consumed during the reduction. So number of electrons exchanged is 6 electrons. So this kind of question can, yeah, seems to be very simple, but if you don't balance properly, you will get land up in wrong answer. Okay, so be careful. Practice more questions. This is very easy. Yeah? Here you should be able to score well. Yeah, you can cross verify this answer by two methods, two steps. In first step, all the entities should be balanced. As you can see here, Fe is balanced, chromium is balanced, oxygen is also balanced, hydrogen is also balanced. And second one, charge balance should be there. 6 into 2, 12. 2 minus or minus 2 I can say. 14 into 1, 14. And here it is 18. 6 into 3, 18. 2 into 3, 6. And 7 into 0, it's neutral. So 12 minus 2 is 10 plus 14, 24 is the charge on left side, and 18 plus 6, that is 24, is charge on the right side. So it is balanced. Okay, yeah. So hope you understood all of this. So in the next class, we'll go into application of redox reaction. Yeah, in titration and all.